model. Before going to solve problems, so I need to focus 4 points. One is the nucleons in a nucleus move independently, a common potential determined by the average motion of all other nuclei. Protons and neutrons fill the energy levels separately in the nucleus. The most of the nucleons are paired. So a pair of nucleons contributes zero nuclear spin and zero magnetic moment. And the last important point is the property of the nucleus are found by single unpaired nucleons. Single unpaired nucleons. Remember this. Okay. So first we're going to solve these problems related to the nuclear shell model. Find the nuclear spin and parity of the uh, even nuclei, odd nuclei, even odd nuclei. Okay. So our aim is to okay, find the nuclear spin and parity. So J nuclear spin, okay, and is the parity. The first example which we are going to discuss, number one, first example. For example, if you take oxygen, 16 is 8. So we need to write the notations first, right? So P, I mean, protons are, number of protons, 8 are there. Number of neutrons, 8, right? Okay. So first one, S1 divided by 2. So this will two paired electrons, right? The next one, P 3 divided by 2 is 4. Next one, P 1 divided by 2, this is the total number of 8. So how we can remember these things? So S 1 divided by 2, P 3 divided by 2, P 1 divided by 2, P 5 divided by 2, yes, 1 divided by 2, D 3 divided by 2. This is the order. So I'm taking this order, right? Okay. These are the pair of nucleons. Pair of nuclei. The magic numbers. Okay. So in this similar way, you can fill S 1 divided by 2 is A, and P 3 divided by 2 is 4, P 1 divided by 2. So if you observe here clearly, there is no single nucleus. As I said earlier, the properties of the nucleons are found by the single unpaired. So here there is no single unpaired nucleus. So therefore, J equal to 0. J equal to 0. And and parity equal to positive. Okay, parity equal to positive. Or else we know this formula, right? I equal to minus 1 whole power. So if you put L equal to 0, you can get automatically positive, right? Okay. So therefore, this nucleus spin is 0, J by spin is 0, okay, parity is plus. This is the answer. This is even nucleus. What happen if you, in case if there even an odd nuclei? For example, for example, carbon 13, 6 is here. So here number of protons are 6. Number of protons 6, right? The neutrons are neutron 13 minus. So therefore, the neutrons are 7. So if you arrange these protons as 1 divided by 2 state, 2 proton, P 3 divided by 2, 4, so 6 is enough. Yes, 1 divided by 2 whole square, sorry, 2, not square, 3 divided by 2, the number of, number of nucleons 4. Final one, the P 1 divided by 2 whole power, right? P1 divided by 2, 4, 6, 7. So we need to focus on this step. So even odd, right? So from here itself, we can find. So what is J value here? So we already know the spectral term L, J. This is L plus S, right? So this is L. What is J value here? 1 divided by 2. J equal to 1 divided by 2. Only you can focus on this. What is L value? P L value is 1. So we need to find the parity. Parity pi equal to minus 1 whole power. So that equal to minus 1 whole power 1 are equal to minus 1. So therefore, spin parity of this nucleus is J I equal to spin is 1 divided by 2 and parity is minus. Okay, this is the even odd nucleus. Example. Next, what happen if the nucleus is containing the, for example, odd nucleus, odd nucleus. If you take the example nitrogen 14 is 7, right? Uh, number of protons are 7. The number of neutrons 7. If you try to arrange this, fill the energy level. First state is S1 divided by state. Okay. E 3 divided by 2, 4, 7, right? P 1 divided by 1 divided by 1. 4, 6, 7. Okay. This is also S1 divided by 2 square. P 3 divided by 2. P 1 divided by 2. So if you try to clearly observe here, so this portion we need to focus right here. I mean property of the So here, what is J value here? We need to know what is J value here. J1. This is J2. Okay. What is J1 value here? 1 divided by 2. What is J2 value here? 1 divided. What is L1 value here? P, right? 1. What is L2 value here? By using these two, I'm going to find the parity of this. Parity equal to minus 1 whole power 1 plus. So I'll tell you this is L1 plus L2 equal to how much this one. In case if you get odd no, you try to write this type of parity equation. Phi equal to minus 1 whole power L1 plus L2. Instead of L, we need to add 2 orbital angular momentum of the nucleus. No, not nucleus, nucleus. Minus 1 whole power. This is 1 plus 1 because here 1 is here. So then we can get 1. So here also, if we try to add the we try to add this pi, the same thing we can get, right? Okay. This is also 1 parity pi. So therefore, this type of nucleus J pi equal to, so what is J1 plus J2? Total J is equal to J1 plus J2. J1 plus J. So 1 divided by 2 plus 1 divided by 2. J is equal to 1 divided by 2 plus 1 divided by 2. 1 whole power. This is how we can get the answer. So this is one rule is there here, that is rule 1 L1 plus L2. So according to this rule, so if you add, for example, J1 plus J2 plus 1 plus L2, you add like this. So in case even nuclei, even if you find even, okay, you need to find J value like this. J is equal to J1 J2. If you find the odd nucleus, J1 plus. So this is the rule. We need to follow this shortcut. Find this type of odd nucleus. We need to follow this rule. Okay. Okay. So now we can check this type of problems, previous CSIR net problems. The first one is this is GATE 2010 problem. Find the spin parity of 50. They're asking. So it is already there right here, not 14, it's there, 15. So they didn't give any number here, the proton number. Okay, we already know the proton number values. So we know the what is the uh, neutron number here. Neutron numbers are number of neutrons 8. Okay, so number of neutrons is neutrons are 8. So and protons are 7. Okay, this is 7. Okay, so 8. Okay, so S 1 divided by 2 power 2, P 3 divided by 2 4 6, P 1 divided by 2. So let us come to the neutron. S 1 divided by 2 power 2, P 3 divided by 2 power 4, P 1 divided by 2 power. So we need to focus only paid states, right? This is only on paid state. So this is even odd nuclei, right? Even odd nuclei. So we need to find here what is J value here. What is J? J equal to 1 divided. What is L? L equal to P. So therefore parity pi equal to minus 1 whole power L, that equal to parity equal to minus 1. So our answer is J pi, right? So what is J value? 1 divided by 2. So what is the parity? Minus. So this is the answer. Correct. Next, oxygen. So maybe, yeah, oxygen here is there. So they are given oxygen 17. Okay. So similar thing they are finding 2010 there, 2011, 2008, 2011 question. Okay. Find spin and parity of the this nucleus. Oxygen 8, 17 there. The number of protons are here. The number of protons are 8. Okay, number of protons are 8 here. That according to give data. Number of neutrons. So how many neutrons are there? If we need to try to arrange these values, so so now need to focus on this thing. Okay, so just you try to fill this one. S 1 divided by 2 whole power 2. S P 3 divided by 2 power 4. Next thing P 1 divided by 2 so 8. So what is the next state? I'm very bad at remembering. Just have to check. S divided by 2, P divided by 2. Next D 5 divided by 2. Okay. We need to remember these things always, right? D D 5 divided by. So this is 8 9. So in case if you want to find as rules, fill this one also. S 1 divided to P 3 divided to 4 P 1 divided by 2 8, right? It is enough. So here no need to focus here. We need to focus only this unfilled state. Okay. Here I'm going to focus this unfilled state. So here what is J value? J equal to 5 divided by 2. So what is L value here? 2, right? So what is parity? I equal to minus 1 whole power L, that is equal to minus 1 whole square, that equal to 1 is positive. So therefore our answer is J pi, right? That equal to what is J? 5 divided by 2 whole power. This is correct answer. So here I'm not giving any options. Actually, they are giving some options. So here we try to follow each and every question. Get next question. Um, Carbon we already discussed, right? Yeah, this question there asked already again. 2000 one 2050 carbon 16, but they're asking different type of formation. The frame of question is very different from. Okay, okay, this maybe we can go and discuss this one clearly. I'm going to write this. They're asking 2015, like this in nuclear shell model. The potential is modeled as V of R equal to 1 divided by 2 m omega square r square, and some perturbation is there, lambda L not lambda greater than 0. Okay, so they are finding they're framing this question like the correct spin parity and isospin, so isospin of the ground state, carbon. Okay, carbon that. So we know the here the protons of protons are six of protons, carbon 613, right? So we already discussed this carbon here six. Extra they are asking about this. What is the isospin? So isospin is minus one divided by the option they clearly given different type of option, but we can find easily this isospin value. We know how to find the isospin value, right? So I3 values, isospin values. This is the answer. But they're asking different type of formation. Okay, clear question, but they're asking different. Next question. Uh, Again, they are asking 2016 8 8 2000. Find the spin and except spin parity values. Okay, only spin and parity of oxygen 8 and 7. So spin and parity of this oxygen. The different type of nucleus they are asking here. Okay, so we already discussed oxygen 10, right? Oxygen 17 we already know. What is oxygen 5 divided by 2 plus? So we need to find oxygen 15. Yeah, 15. So oxygen 17 is it is already there in previous. So here I'm going to find this one. Okay. So their options are given like this. Option A, in case if you can use A equal to 1 divided by 2 plus 1 divided by 2 minus. Option B is 1 divided by 2 minus 5 divided plus. Option C is 3 divided by 5 divided. Option D is 3 divided by 2 minus 1 divided by 2 minus. So it is clearly indicating option A and B is not related to. So we need to find option B or option. So we already know this oxygen 817 spin and battery value. This was just only 5 divided by 2 plus. Okay, this answer is 5 divided by 2. Battery is 4. So we need to find this one. Oxygen, oxygen 815, right? So okay, number of protons 8, number of neutrons are 7, right? So yes, 1 divided by 2, 2, P 3 divided by 2, 4, next P 1 divided by 2, 8, right? Yes, 1 divided by 2, 2, P 3 divided by 2, 4, P 1 divided by 2, power 1, 4, 6, 7. Okay, so we need to focus this unfilled state uh, from this. What is J value? So it is already there. J value 1 divided option B is correct answer. Minus for your complete L equal to 1, right? Find what is J value minus 1 whole power L minus 1 minus 1. Okay, option B is the correct answer. Next, so carbon 30 2017 8 2017 2008 8 2017 again there are question carbon 613 find the spin back of this nucleus. Okay, carbon 13, see here carbon 13